Now let us go through the figure it out of this concept of divisibility. So first we have here is 2024 is the leap year, and leap year occurs in the year that are multiples of 4, except for those years that are evenly divisible by 100 but not by 400. So what we have to do here is, from the year you were born till now, which years were leap years? Let us try to calculate this. So let us take that you are born in year 2014, let's say. Okay, and from 2014 till 2025 going on, let us write down all the years here. We have 2014, 2000. Let's not write all the years. Let's start doing this. Okay, so now what I want to do is, I want to find out whether this is a leap year or not. So to find that this is a leap year or not, what I'm going to do is, I'm going to check the last two digits. Since the last two digits are 14, which is not divisible by 4, because we know that the leap year, it occurs at the interval of 4 years. So what we are going to do, we will check if the given year is divisible by 4 or not. And for that, we are going to check the last two digits, because to check if a number is divisible by 4, we will see the last two digits. So 14 is not divisible by 4, so it's not a leap year. Then 2015, 15 is also not divisible. Next we have 2016, because 16 is a leap year, it is divisible. Then after 16, 2017 is also not divisible. 2018 is also not divisible. 2019 is also not divisible. Then we have 2020, because it is divisible. Or what can you do here is just write down the multiples of 4 after 14. So we have 16, 20, 24, 28, 32, 36, and so on. So let's do this. So 2020 is a leap year. Then 2024, this was a leap year. And now the next leap year, it will come in 2028. Okay, so you have to find till 2025. This is done. So the leap years were 2016, 2020, and 2024 after 2014. These are the 3 leap years. Now, this is done. From the year 2024 till 2099, how many leap years are there? So how we can do this, kids? Again, we can write down the multiples of 4 starting from 2024. So I can start writing the multiples from 24 till I reach 99. So let's do this. What we have here is 4, 40, then 44, 48, 52, we have 52, 56, 60. Next is 64, 68, 64, 68, 72, 76, wait. Yeah, 72, 76, and 80, 84, 88, 92, 96. And after 96, it will be the 3000 here. So what I have, it will be the plus 1 plus 4 year of this. So what I'm going to do here is, these are all the multiples of 4 after 24 till 99. Okay, where we will have leap years. So I can just add now the year to it. That is 2024 is first leap year, 2028, 2032, 2036, 2040, 2044, 48, 52, 56, 60, 2064, 2068, 2072, 2076, 2080, 2084, 2088, 2092, and 2096. All these are less than 2099. Okay, and the next one will be 2100, which will be out of this range. So we are not writing that leap year here. So these all are the years. So I hope you understood what we have done. Starting from 24, the last two digits, till 99, we have identified the multiples of 4. Okay, and on all those multiples of 4, we will have the leap year. After identifying the multiples, I have just added the 20, this 20 number to it, so that it will form a complete year. Done. Now next we have here is question number 2. Wait. Yeah. So question number 2, I'm taking, find the largest and smallest 4-digit numbers that are divisible by 4 and are also palindromes. So kids, I hope you remember what are palindromes. They are the number which reads same from right to left and left to right. First of all, what we have to find? We have to find the largest 4-digit number. Okay, which is a palindrome also, number divisible by 4, which is divisible by 4, and a palindrome also. So kids, we know that what is the largest 4-digit number first. Okay, that is 9999. Is it divisible by 4? No, it is not divisible by 4 because 99 is not divisible by 4. Okay, so now if I try to take 98 here, if I try to take 98 here and see if it is divisible by 4, it is also not divisible by 4. Now if I just go down and take 999 and 96, we know that 96 is divisible by 4. Okay, so it is the largest 4-digit number. It is divisible by 4, but it is not a palindrome, right? It is not a palindrome. Why? Because if we have to make it palindrome, then here we should have 6. Okay, so this is not the largest 4-digit number which is divisible by 4 and a palindrome. So that means what we need here is, we need here such a number that it should have same number on both the side and it should be largest also. So to do that, let us go to the, because we cannot write 6 here, because 6 will be little smaller. Let us try to go in the 8000 range. Okay, so what I am going to do here is, I am going to write the 2 digits which are in 800 series and are completely divisible, because if I'll get 8 here, then I can also write 8 on the other side to make it palindrome. So if I see the number here which is the largest, that is 88. So what I'll do here, I will write down 88 because I know 88 is divisible by 4. And now to make it palindrome and a 4-digit number, I'm writing 88 again. Okay, so this 88 is divisible by 4. This criteria is done. This complete number is a palindrome, done, and also this is the largest 4-digit number. Okay, so we have got this number 8888, and I hope you understand how we have done, because in 9000 series it is not possible. It is possible to get the 4-digit number which is divisible by 4, but we will not get palindrome then. Okay, so that's why what we have done, we have moved to the 8000 series, and in the 8000 series we have this number 88. So this number 88, using this number we can easily form a palindrome number also. It is divisible by 4 also, and also it's a 4-digit number. So answer to the largest number is 8888, which is a palindrome. Now next is, we have to find the smallest number, smallest 4-digit number also. So kids, in order to find the smallest 4-digit number, we know that for smallest 4-digit number is 1, 2, 3, 4. This is 1000 and this is the smallest 4-digit number, but it is not a palindrome, right? This number is not a palindrome. Let us try to find a palindrome number here. We have 1, 2, 2, 1. Again, this is not a palindrome. 1, 1, 1, 1. Again, this is not a palindrome because, sorry, these are palindromes, but these are not divisible by 4. Again, this is not divisible by 4. So what we are going to do here is, in the table of 4, let us write down, sorry, let us write down the first multiples of 4. So we have 4, 8, 12, 16, 20. These are the first 4 smaller numbers. Okay, so let me try to start with 4 here. If I take something like 0, 4 here, okay, and 4, 0 here, then this is 4004. This number is a palindrome. It's a 4-digit number also, but is this a smaller number or not? This we can check. Okay, so I'm just keeping this number aside. Okay, we will consider this. Now let us try to make another number with 8. So kids, if I'll make it with 8, it will be very large because it will come in 8000 series. So I will not take 8. Next, what I'll try to do is I will take 12. So using 12 at the end, I will get 12, and to make it a palindrome, I can write 21 here. So in this number, it's a 4-digit number, it's a smaller number, and it has 12. This number is divisible by 4 also. It's a palindrome also. So we can also consider this number. Now let us move further. We have 16 also. Similar way, I can use 16. Okay, I can use 16 here also. 20, if I want to use 20 here, it will be something like 20 and this 02 and 02. But this 0202 is not a 4-digit number from both the sides. So I cannot take this number. So I am left with 3 numbers now. 4004, 2112, 6116, and out of this number is the smallest number. So the smallest number, which is a palindrome and a 4-digit number and divisible by 4, is 2112. This is the smallest number. Okay, I hope you have understood this, how we have find this out. We are using the multiples of 4 to find the lowest number, which is a divisible by 4 and which is also a palindrome, and the smallest number as well. Now this is done. The next one we have is true or false. Explore. Okay, sum of two even numbers give us a multiple of 4. So kids, this is not always true, because if I take 2 as one even number and 8 as another even number, it will give me 10. And 10 is not a multiple of 4. So this is a false statement. This is not always true. Okay, but if I take 2 plus 6, it will give me 8, which is true, but it is not always true, so we will mark this as false. Next we have sum of two odd numbers give us a multiple of 4. So I am taking here, let me take 3, and let me take the another number as 7 here. So again it will give me 10, which is not a multiple of 4. So this is false. At the same time, if I take 3 and 1, it will give me 4, which is a multiple of 4. But again, since it is not always true, so I have marked this as false. Okay. So now let us take the another question, question number 4. Okay. So this is false and false we have done. Now answer 4. Find the remainders obtained when each of the following numbers are divided by 10, 5 and 2. So kids, I'm leaving this question to you. This is very, very easy. Okay, what we have to do is, like, first of all, I'm taking a number 78. You have to divide it by 10, 5 and 2. So we know if we divide this number by 2, it will be completely divisible, but it will not be completely divisible with 5 and 10. Okay. Similarly, 99, if we take, it is not completely divisible by 3 of these. But what is the remainder? This is simple division. You guys can do. So in all the cases, we have to do this. But let me quickly go through all the numbers and tell you. For 173, it is not divisible by 3 of them completely. 572, since 2 is the even number, it will be completely divisible by 2, but not with 10 and 5. And for 980, since 0 is there, so it will be divisible by 10 completely, with 5 and with 2 also, because it comes in the category of even numbers. Then we have 1111. So here it will not be completely divisible by any of these numbers. And finally 2345, since we have 5 at the end, it will be completely divisible by 5 but not with 2 and 10. But about the remainders, kids, this is a homework for you. Next, question number 5 we have here is, the teacher asked if 14560 is divisible by all these numbers. Guna checked for divisibility of 14560 by only 2 of these numbers and then declared that it was divisible by all of them. What could those two numbers be? Okay, let's see. So what she has done is she has tried to divide it by with two numbers to see if it is divisible by all or not. So what are those two numbers she has chosen here? See, it is divisible by 2 because 0 is there. Now, if I try to divide it by 60, we will consider both the digits, because for 4 we will use 60 by 4. So it is completely divisible. It is divisible by 4. With 5 also it is divisible because we have 0 in the end. And if I have to check for 8, what we will do? We will try to divide by 5. With this 5, 60 by 8. So we will get 70. This is also completely divisible by 8. And finally with 10 also. Okay. So we know that this number, it is completely divisible by all the numbers. Okay. Now, question number 6. Which of the following numbers are divisible by all of these? So kids, this I am leaving to you as homework. I am just giving you a quick hint here. With 2, we know this number will be divisible. All the numbers will be divisible by 2 here. Why? Because we have either even or 0 at the end. Now, with coming to 4, we will check the last two numbers. This will be divisible with 4, 52. 52 will also be divisible with 4. We have to check the last two numbers. So this also you have to check. You know the things that how we have to check. To check with 2, we will have to check the even. For 4, the last two digits. With 5, all the numbers are not divisible by 5. At least these two numbers are not, because it doesn't have 0 or 5 in the end. Okay. And same with 10. The first two numbers are also not divisible by 10. So since we know that all which of the following numbers are divisible by all of this, first two numbers will not come in that criteria, because they are not divisible by 10, they are not divisible by 5. So now we have these three numbers. What you have to do is you have to pick these three numbers straight away, and you have to see these numbers, they are divisible by 2, 4, 5, 8 or 10. See, these three numbers, they are divisible by both 5 and 10. Why? Because they have 0 in the last term. Now what you have to check here is, also these numbers have 0 at the end, so they are also divisible by 2. What you have to check now, whether they are divisible by 4 or and 8 both. So to check with 4, just pick the last two numbers. To check with 8, just pick the last three numbers. Okay, and this is a homework for you. This is very easy. So by now you should be able to know that how we have to check. Okay, next is write two numbers whose product is answer 7. This I'll do for you. 1, 2, 3, 4. This is the product. The two numbers should not have 0 at the unit digit. So kids, the easiest way to do this is, let's try to break it. Let's try to do the prime factorization. So we can write this as 4 times 10. Now I can break it down further into this as 2 and 5. Similar way for the other 10s. Right? So what are the two numbers? The two numbers are clearly 2 and 5, right? So these are the two numbers whose final product will give us 10,000. Clear? So this is also done. So kids, we are done with this exercise, and I hope that you have understood the rules of divisibility.